What is proof of work? Originally dated back to 1993, the proof of work concept was developed to prevent denial of service attacks and other service abuse such as spam on a network, by requiring some work from the service user, usually meaning processing time by a computer. In 2009, Bitcoin introduced an innovative way of using proof of work as a consensus algorithm that is used to validate transactions and broadcast new blocks to the blockchain. It has then spread to become a widely used consensus algorithm in many cryptocurrencies. How does it work? In short, miners on a network will compete against each other in solving complex computational puzzles. These puzzles are difficult to solve, but very easy to verify the correct solution. Once a miner has found a solution to a puzzle, they will be able to broadcast the block to the network, where all the other miners will then verify that the solution is correct. Let's take an example. Bitcoin is a blockchain-based system that is maintained by the collective work of decentralized nodes. Some of these nodes are known as miners and are responsible for adding new blocks into the blockchain. In order to do so, miners need to try and guess a pseudo-random number, aka nonce. This number, when combined with the data provided in the block and passed through a hash function, must produce a result that matches given conditions, for example, a hash starting with 4 zeros. When a matching result is found, the other nodes will verify the validity of the outcome, and the miner node is rewarded with a block reward. Therefore, it is impossible to add a new block into the main chain without first finding a valid nonce, which in turn generates the solution of a specific block, called block hash. Each validated block contains a block hash that represents the work done by the miner. This is why it's called proof of work. Proof of work helps to protect the network against numerous different attacks. A successful attack would require a lot of computational power and a lot of time to do the calculations, and therefore it would be inefficient since the incurred cost would be greater than the potential rewards for attacking the network. One issue with proof of work is that mining requires expensive computer hardware that consumes a large amount of power, and while the complicated algorithm calculations guarantee the security of the network, these calculations aren't able to be utilized beyond that. While proof of work may not be the most efficient solution, it is still one of the most popular methods of reaching consensus in blockchains. There are already alternative methods and approaches trying to solve the problem, but only time will tell what method will be the successor of proof of work.